you doing?
I'm good, thank you.
tired?
Yeah. I feel like wistfully looking out the window.
Me too, me too. Embrace this weekend, because it's, I think, gonna be the last, like, warm, short stay weekends of the year, so, yeah. Just embrace it. We have what to do today, What time's that due? 11:59. What do we have next week? Quest. Which quest? Quest number? 4. Quest number 4. All right, I think it's 12. Why don't we stand up? Okay, normally at this point in time, in my regular sections, I just have you slap somebody across the face, but now it's COVID, so we can't do that. So pretend slap each other. Come on, pretend slap each other. Okay, tell them wake up. Say, wake the hell up. Say, wake the hell up. Okay, sit back down. Okay, so what is this?
Daily confirmed new cases.
Daily confirmed new cases, okay. Which line are we?
Probably the top one.
Is it green?
We're the green, yes, we're the green, okay,
Yay.
okay, I know, we shouldn't be laughing. Okay, but it's just like, let's talk about some of the concepts we've been talking about. Have we been talking about increasing and decreasing?
Yes.
Okay, so if we look at the US, which happens to be the green line here, as far as increasing and decreasing, in March we started increasing, and then we went through a major shutdown and we started decreasing, and then about June we opened back up, and then we increased, and then we started heading into the fall, and then all the college kids went, sorry, okay, that's right. Okay, now what are we doing?
Halloween.
That's Halloween. Okay, so we're increasing. Okay, so mostly we've been increasing. There was some periods where we were decreasing. Okay, but now what does it look like?
It's a skyline.
Okay, so now let's talk about concavity. In the beginning, we looked like we were concave up, and it looks like we're about right here. We have a inflection point where our smile turns into a frown roughly, and then it's kind of like a little hard. But we're just kind of looking. And here, roughly, it looks like we've got another inflection point where we went from concave down to being more concave up. Here we're switching again, and so we're concave down, okay, until about right there. Then suddenly we're concave up. And guys, it doesn't look good, right? I mean, it looks like we are, which means the derivative is increasing at a faster and faster rate. And as far as COVID is concerned, that means we're getting worse. But we also have to remember that testing has gone way up. I mean, at UPark, they say, come, we've got how many tests do they say that UPark they have? 1,000. Every Wednesday they have 1,000. So I'm just like, I've never been tested. Maybe I should. I don't have symptoms, but maybe it'd be fun to get tested. Has anybody been tested in here? Is it fun to get tested?
No.
No. Okay.
The self-test is fine. I
The
haven't
what?
had to like shove the thing up my nose.
Who's had to shove the thing up their nose? That doesn't seem so pleasant. That doesn't seem, is it not
It made me
pleasant?
cry.
How high up do they go into your?
Like all the way
Right
up.
there.
Until they can't.
Gray matter, okay, forget it, I'm not getting tested, okay. But my mother-in-law's getting tested today, so I'm just wondering, do I go home or do I not go home? That is the question. If we look at France, it looks like they were concave up, and then suddenly they're, I guess maybe right there, deflection point, then they're concave down, and it looks like they're doing a little bit better. Do you see how these concepts have relevance in life? Do you see how these concepts have relevance in life? Okay, so now, when you're talking about math, we're often talking about mathematical models. And you guys aren't ready to handle real mathematical models. How many people realize mathematically you're not ready to handle real mathematical models? So we've got some easier mathematical models like this. We have this function which is very different than the functions we were looking at last time. Last time when I asked you for concavity, please find me intervals where I'm concave up, find me intervals when I'm concave down, find my inflection points. When they were polynomials, it wasn't so bad, but this ain't a polynomial. We've got a fraction here. In fact, there's two bad values. There's two Gary Dreibelbisses who's never allowed to get a baseball bat. One and -1, because they're going to cause division by 0. Okay, so now, I want to find when is this function that I cannot even really imagine what the graph looks like, when is it concave up and when is it concave down? What do you do? What's step one?
Take the derivative.
find the first derivative. So you guys do that. You guys do that. I'll get your brains going. You guys find the first derivative. I'm so bad at social distancing. This 6 feet rule just is killing my class. I'm so used to just being down on my knees around groups of students, kind of like a Outback waiter. And really, for the first time, because we're going to take a second derivative, I want you to simplify it. This isn't like the last quest where I just say take the derivative, don't worry about simplifying. Simplify that numerator as much as possible. What rule do you need to use to start it? I'm looking. Quotient rule, quotient rule. Because I could see a problem like this, maybe not quite this involved, but a problem like this next Friday. Next Friday we have our quest. Elementary school, all I did was look out the window. That's all I did. That was all I remember of elementary school. Okay, wherever you're at, stop. Wherever you're at, stop, and show what you have to somebody else. Show what you have without breathing on them. Show what you have. See if you're getting the same derivative.
I didn't even get it. I tried to simplify.
You're good, you're good. Lainey, you have a fraction. What's in the denominator?
Did you get that? When you did the-
Yeah, because I don't really, oh, I don't get to like simplify it to ever like.
Okay, so now I am going to take the
I did
reins
not see that.
and make me number one, just like you're watching me on the grid. Okay, now I've now broken you out of your groups. What rule do you have to use to start? Quotient rule. How many people know quotient rule? Please say yes. Okay, so now, it's pretty easy in the basement. What do you do with the denominator? Square it. You just say, okay, let's do that. No derivating, that's not even a word. Derivating at all. How many people like, that's pretty simple. That's pretty simple. The numerator. Do I take the derivative of the numerator or denominator first in quotient rule? And what is the derivative of x squared? 2x. Don't worry about the denominator, just multiply times the denominator. So we have x squared minus 1. What's the connection sign in this rule? Minus the numerator times the derivative of the denominator. But what's the derivative of the denominator? 2x. How many people got to that place? How many people got to that place? Okay, so now, on the last quest, it was like, stop. You don't need to simplify. Don't simplify was on there. But now, are we going to be done? Can we find concavity from this derivative? We need to take the second. So now, get out your broom, your algebra broom, and let's sweep this up. Let's sweep this up. Here, I get a 2x cubed. This goes to both of these. Then minus 2x. And then here I would get a
minus 2x.
And then all over x squared minus 1 squared. Now what nice thing happens? What nice thing happens? Yep. It's Halloween, things die. And we're left with minus 2x over x squared minus 1 squared. Now, are we done with the problem? Are we done with the problem? No, now we have the nightmare of taking the second derivative. So now, at your seats, do the very best that you can in finding the derivative of that box. So go ahead, have at it. Try to find the derivative. I'll give you a hint, it's quotient rule again. And you're gonna need to use power chain at some point in time.
Do we have to simplify that too?
You probably want to simplify the numerator. You probably want to simplify the numerator as much as you can. I mean, I see some are struggling and then I can't get near you. Is this harder or easier than the one we just had? Is this harder or easier? Please say harder. Please say harder. Okay. So wherever you're at, stop. Wherever you're at, stop and at least explain to somebody else what you were trying. At least explain without reading on them. Explain to somebody else what you were trying.
Do the quotient for what
Oh, yeah.
Well, yours is
I got
a lot
the
bigger.
denominator.
Yeah, no, I just simplified
That's what
further
this
because
is,
I want to
and
make
then I
sure.
got
You already started simplifying.
And then I tried to start simplifying, I like messed up on it. So after looking at it.
Yeah, I got it.
Yeah,
I
just-
did simplify it. and I-
Mason, did you show somebody what you had? Okay, good.
Oh, wait, this wouldn't be square.
Do you see how much more fun it would be if we could all be in groups and all make
Wait, how?
This negative.
Oh, let alone Zoom where we
Yeah,
got.
instead of simplifying.
negative.
Okay, cool.
Do those breakout rooms work at all, or is that just a
No,
total?
you're fine.
So what do you guys think?
Yeah, okay.
We're voting now. Breakout rooms in Zoom, useful or not useful?
It
I don't
depends.
care. I don't care. I don't care about breakout.
I just find them awkward.
Sometimes people don't talk and then it's not useful.
Exactly.
People don't talk?
It's
Like,
like
sometimes
that's
they do,
not
it
just in yours,
depends.
just every breakout room, there's always someone that doesn't talk, or doesn't
Yeah,
have a
that's
camera
Just,
on.
do people not turn their videos on?
No, sometimes.
Some of the videos are most.
In this
This
class,
class.
yeah,
This
but
class, yeah, your class has like the best turnout in the breakout rooms, I
I trust y'all.
Okay. Yeah, the fact that I'm like many of your only on in-person teachers, I'm just like, what the hell, right? I'm reporting, okay? But I mean, how many people realize if you don't go to like a regular classroom for a year and a half, that's going to be really hard to go back to a regular classroom. If you're used to like laying in bed and just going to class by laying in bed, how many people realize like next year it's going to suck when you can't, you actually, that's why I'm like, I've got to keep my kids coming to class and they've got to get paper tests or else they're not going to remember. They're not going to remember how to do this.
I miss paper.
Yes, I miss paper too. Now, I think this chair is broken, so if I fall, okay, you guys can
Please
just
don't
leave.
fall.
You guys can just leave. Okay.
Okay.
All right. I got to use quotient rule. True or false?
True.
So what's in the bottom? What's in the bottom? Let's not even think. What would be in the bottom?
Denominator squared.
X squared minus 1
To the fourth.
squared squared. So that would be x minus squared minus 1 raised to the fourth. Anybody get that? Did anybody get that? Squared squared, which is to the fourth. So now I'm gonna need some help. what's the derivative of the numerator? -2, so let's put that there. -2 times the denominator, but the denominator is x squared minus 1 squared. What's the connection sign? What's the connection sign? Minus the numerator. Now what's the numerator? Okay, now comes the hard part. This is when all hell breaks loose. I've got to take the derivative. I've got to take the derivative of the denominator. Now I'm just going to do this over here because I don't want to have to rewrite this whole fraction all over again. But you want to take the derivative of x squared minus 1 squared. But this is this flashcard. What's the power chain rule derivative? The derivative of a function raised to the k is, help me, k times f of x to the times the derivative of x. Now you guys help me out. Who's the exponent? Who's the k? 2. So if I take the derivative of this, it's going to be 2 f of x, which is just to the 2 minus 1, and that's just 1. And we don't even really put it there because now times the derivative of the inside. But what's the derivative of x squared minus 1? 2x. So this is the derivative of this denominator. This is the derivative of the denominator. So now I'm going to put it in this box. In fact, you put it in the box before I do it, because if you write it, that'll help you remember it. You write what the derivative, you write the derivative of the denominator. Okay, it's right here, There's nothing that hard. Write the derivative in there, and you would have 2, let's see, 2 times 2 is 4, so I'd have 4 x times x squared minus 1. Did anybody get to there? Did anybody get to there correctly? Probably less. Okay, most of the time, at this point in time, if we were doing this, we'd be done. But we want to find intervals of concave up and concave down. So let's sweep this numerator up a little bit.
I have a question. When you have the connecting minus sign in the middle, would you also bring the negative from the 2x in the numerator? Or would you just keep it?
Oh, bless your heart. Yes, that would be a plus. Thank you. Thank you. Yeah, I completely forgot about my minus hanging up there. Thanks for saving the problem. Okay, let's clean this up a little bit. 2x times 4x.
X squared.
So we've got that. So we'd have minus 2 x squared minus 1 squared plus 8x squared times x squared minus 1.
Wait, Professor, wouldn't you keep it as minus and then all in brackets the negative 2x times all that stuff?
Yes, but that would change
It
that
would still
to a
end
plus
up
out.
changing it out. Okay, I didn't know like after distributing.
No, that's a good question, but it would end up being a plus.
Okay.
How many people understand from going from there to there? Okay, now, what can we pull out of the numerator? What do we have alike? One thing I noticed is we got 2, and we've got 8 there. We don't have an x squared, but what else can I pull out? What else can I?
Minus 1.
I've got an x squared minus 1, and I've got 2 of those there. So I want you guys, I'll pull it out to here. I want you guys to write down what would go inside there. You guys look at the line above, use your algebra skills. You're pulling out an x squared minus 1, and I guess I'll pull out the 2 also. Okay, for sake of time, if I pull the x squared minus 1 out, and I pull a 2 out, what's the only thing left with that term? What's the only thing left with that term? 4x squared. I've got a 4x squared here. I pulled the 2 out, I pulled a 2 out, and I pulled the x squared minus 1 out. Now for the harder term. If I pull a 2 out, would I still have the minus there? If I pulled the 2 out, would I still have the minus there?
Yes.
If I steal one of the x squared minus 1s, if I pull one of the x squared minus 1s, what's left there, guys? What's left there?
1x squared minus 1.
Very good, Lorelai. 1x squared minus 1. And so this would be minus 1x squared minus 1. You're like, Dr. Warren, this is a lot of work. No, I know. See how much harder it is when it's a fraction than when it's a polynomial. You're like, Dr. Warren, what the hell are we doing it? What are we actually doing here again? Oh, we're trying to find intervals of concave up and concave down. Oh, I forgot that altogether, Dr. Warren. Okay, now, you're like, Dr. Warren, certainly we're done. No, we're not done. We're still sweeping. You've created a mess. Okay, you've got an x squared minus 1 here. How many people see the x squared minus? Raise your hand if you actually physically see the x squared. How many do you have down here in the bottom? How many do you have down there in the bottom? 4. Could I get rid of 1 from each of them? So if I killed that guy and removed 1 of them from there, how many would I have down there? 3. So let's put that in. That's at least going to help me.
Wait, Dr. Warren, where did the squared go from the -2 times x squared minus 1 squared on the left when we got to the thing on there?
We stole 1 here, Alex. Do you see this? This has got 2 of them.
Uh-huh.
This has had 1. We factored that all the way out. We factored 1.
Oh,
of
we
those.
just stole it from
It's
both
the
sides. Okay,
GCF
thanks.
in this case.
Thanks,
The
Lola.
GCF, the greatest common factor.
That makes sense, yeah.
It's almost like, trust me. Imagine that I've got this, and I pull the 8 out. What would I have left here?
Alright, just the bottom.
5. What do you have left here?
An 8, yeah, I just
8.
didn't look at the very end of the equation.
No, trust me, you're not alone. Okay, let's distribute the minus. No, Dr. Warren, let's not do that. Let's distribute the minus. Then I would get a negative x squared and then a plus 1. Oh, but I've got a negative x squared and I've got 4, so that would be then 3x squared. The negative hits the
3x
minus
squared
1 and
plus
becomes
plus
a
1.
plus 1. Now I've got to ask, are we in better shape? Than where we were? You're like, I'm not sure, Dr. Warren. What did you just do? It's called algebra. I distributed the minus. Let's do this again. And I'd get a,
Negative x squared.
and then I'd get a
Plus
plus
1.
1. So this is my plus 1.
Dr. Warren, what about the 2? The 2 outside?
Oh, bless you, the 2. I abandoned
Oh my
that.
gosh.
Just like my, did I tell you about the time my parents, well, this happened a lot. How many people went on family vacations with their parents before? Isn't that like no fun whatsoever when you're a teenager? I mean, by the time you're going, you're like, okay, yeah, that's, I remember though, I have 6 younger brothers and sisters. We drove in a 15-passenger van. Okay, and at the time there were no seatbelt laws, so we were like ferrets in that thing. I was on the ground driving and pulled into a rest area. In Ohio, in the rest areas back in the 1970s, they didn't have running water. They just had outhouses, and then they had a pump that you could get some well water to wash your hands.
Chris, did you put pictures?
So we get back in the van, Dad being the Marine and a doctor and totally successful, just wanted to, it was all about time. I mean, we got up, I don't know if you've ever had a Marine for a father. You get up at the break of dawn, you get in the car, and then it's about beating and killing the trip. That's what it's about, nothing else. We're on a time clock. We drive away, and then I start looking around for my baby sister, Connie. And I start looking under suitcases, looking everywhere else. I realize she's not in the car, and I realize my parents have no idea that she's not in the car. So I'm like, does anybody see Connie? And at that moment, my mother, who's completely paranoid, Chuck, that was my father's name, Chuck, where's Connie? Where's Connie? Chuck, where's Connie? They start realizing that they've left Connie. I'm laughing, okay, I'm laughing. And then Dad's like driving down the interstate. And then they like, you're on the interstate. He hits one of the places where the police sit, blows a donut right around that, rocks are spraying. Doesn't even like, I don't even think he lost 5 miles an hour. I think we probably did it at about 80 miles an hour. Gets back on, goes past the rest area, hits the next one, drives back in. My poor sister is being comforted by people on the curb, just bawling. And then she gets in the car, and I'm just thinking, like, you guys should lose your parenting license for this. You should absolutely lose your parenting license for this. Okay. 3 weeks later, the same thing happened.
To Connie or is it?
No, it's to my brother Sam. Just, okay, but enough of that. Back to work. So I abandoned not Connie, but I abandoned my little brother too. I abandoned, okay. Now, did I bring him back? Did I go pick him back up?
Thank goodness.
Thank goodness. Okay, now, what are we trying to do? Dr. One, I completely forgot. Don't forget Connie.
Concave up and down.
Concave up, Connie up, Connie, concave up, concave down. That means I want to create a, do you remember? Sine chart. So I want to create a sine chart for my second derivative. Now a fraction, look at somebody and say that, because I know you weren't listening at all. Say a fraction to somebody, say the word fraction.
Fraction.
A fraction can only be 0. You can only get a 0 out of a fraction when?
If the numerator is
If the numerator is 0. Do you want the denominator to be 0?
No.
Okay, so I can only get a 0. I can only get a 0 when the numerator is 0. But let's come back and look at what we have up here. Can 2 ever be 0? 3. X squared's always positive. And I'm adding 1. What do we know about the numerator? It can never be 0. It's always positive. Well, like Dr. Warren, then there's no values we need to be concerned with. I'm like, have you forgotten? Who was kicked out at the very beginning? Who's the Gary Dreibelbisses that were never allowed? Plus or minus 1. So let's put them in here. They're interesting values. Minus 1 and 1. I know the second derivative. What does D and E stand for? What does D and E stand for?
Does not exist.
Does not exist. Are there any zeros? Are there any zeros? Is there any value that will make that numerator 0? No. Because there's no other zeros, all I've got to do is test. Give me a number that's bigger than 1. 2. Now you guys help me out. The numerator is always positive, so the denominator wins. 2 squared minus 1, positive or negative? Raised to the third. Positive over a positive. So I know I'll always be positive in there. Now as far as concavity is concerned, am I smiling or frowning? Am I smiling or frowning? So I know I'll be smiling in there. Give me a number in between 1 and negative 1. 0. The numerator is always, I put a 0 in and I get a negative. A negative times a negative times a negative is a negative. A positive divided by a negative is a negative. There's no other way for it to change because there's no zeros. If it ever went positive, there'd be a place where it went to 0. And so this means I'm smiling or frowning. I'm smiling or frowning in that. Okay, if you had to guess what's going to happen, if you had to guess what's happening, what do you think's going to happen there? Positive, let's just check it.
That's a
Make
one.
sure you guys
You
are
are too
smiling.
smiling.
I need you guys.
We can't be happy.
I keep abandoning,
I don't know,
I keep
this is too
abandoning
confusing.
just like my parents. I really need to draw what?
Rounding.
Thank you. Okay. If you had to guess, smiling, but let's just check it. Give me a number less than -1.
-2.
-2. Numerator,
Positive.
positive. -2 cubed.
Positive.
You mean squared?
Yeah, you.
-2, holy hell. And I'm filming this. -2 squared.
Positive.
Positive. -1.
Positive.
Positive. Positive cubed.
Positive.
Positive over positive.
Positive.
So I am in fact concave. Well, I'm gonna use the right words. Now you ask, are there any inflection points? Ask.
Are there any inflection points?
Well, there's definitely, we're changing concavity, but we don't exist. Remember, there are points on the graph. We kick 1 and -1 out of the domain immediately. There's no points on the graph. There's no points on the graph. These are vertical asymptotes for this function, so there really isn't an inflection point. When am I concave down? What interval am I concave down? What interval am I concave down? And I think you guys can figure out the others. How many people realize it's much harder with a fraction? How many people realize it's much harder with a fraction? Now, I couldn't put something quite this involved, a fraction quite this involved, or that would be the entire quest. Or that would be the entire quest. How many people are getting the ideas for intervals of increase and decrease? Maxes and mins, maxes and mins, global maxes, global mins. Local maxes, local mins. You guys feel like you're gonna, concavity, concavity. Okay. All right. Stand up. Take something out that tells time. Take something out that tells time. What time is it? What time does class end? 50. So how much time do you have? How much more misery do you have? 15 minutes. 15 minutes. Or until Pennsylvania counts its votes. Okay, let's sit back down. Let's sit back down. Why aren't you talking, Dr. Warren? Oh, because I'm giving you a break with my voice. Okay, I've assigned homework. I've assigned homework for concavity. I've assigned homework for increasing and decreasing. I've assigned homework for local maxes and local mins. Your quest next week, your quest next Friday will be on those topics. Local maxes, local mins, global maxes, global mins, intervals of increase, intervals of decrease, concave, up, concave, inflection points. Does that seem like that could make up a good quest? Do you think that would be enough topics for a quest?
Yeah.
Yes.
Okay. What was your WebAssign on?
All that stuff.
Except concavity. And I'm not gonna give you a WebAssign for next week. Anytime you have a quest, I don't give you a WebAssign.
Could you give us like an optional web assign that's not for a grade to practice though?
You know, guys, I guess, yeah, let me. I feel like a bad teacher. You're like, Dr. Warren, you are so bad.
Just the first and second test.
This class, this is your class, this is the way mine looks. Now I'm gonna go open student view.
I haven't heard that since high school.
Is that the way is this the way it looks to you guys?
Yeah.
Yeah. Cause I just wanna come down here. Have you guys clicked on this at all?
Yeah.
Have you played with this?
Oh yeah, I have.
So if you come down here, And if I go to applications of the second derivative, you can click on this. What does that say? Can your eyes
Practice
read that?
quiz.
Practice quiz. And they give you WebAssign like questions that you guys can answer, just like you would on a WebAssign, except that it doesn't count anything. You can do the ones you want, and it'll tell you if you're right or wrong. So it's right there. No, I don't participate ever. And then if you're like, Dr. Warren, I'm not getting it still, they've got these tutorials. Unfortunately, you need Flash, so you'd have to allow Flash. So let me. I hate you. Yeah, I don't think I'm gonna be able to get this up, but you got it, there's a way to make Flash, that's really great, thanks. Okay, maybe that was it.
Determine where the function is concave upward and where it is concave downward. G of x is x over x plus 1. Concavity is determined by the sign of the second derivative. First, the first derivative, g prime of x,
Isn't this so
is
boring?
by
Isn't this so
the
boring?
I
Don't
just
you
said
miss
that.
your
x
ADD,
plus
man?
1 times 1 minus x times 1.
But you know,
All
like, if
over
you
the
don't know what the
quantity
hell
x
you're
plus
doing,
1
is this
squared,
better than nothing? Is this
Yeah,
better
I've
than
used that, it's
nothing?
helpful.
which is equal to 1 over the quantity x plus 1
But I'm just like,
squared,
are you
or
intentionally
the
trying to
quantity
be
x
boring?
plus 1 to the power negative
I
2.
just hear the dude from Charlie Brown, the teacher.
G double prime of x is by the general power
Look at
rule,
what they did that little cheating.
negative
move.
2
We did-
times the quantity x plus
Okay,
1
we're done with you.
That was like even worse than most of those videos.
That's like, Sal Khan is so much better.
Okay, stand up again, stand up again. Look at somebody and say, oh no.
Oh,
no.
Here we go.
Here we go.
go.
Say it again.
Oh, no.
Oh,
Here we go.
Okay, sit back down.
Where are we going?
Well, we're gonna have to introduce a function you did not like much in high school.
Oh, is it?
Dun, 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 dun.
I'll give you the master brain.
No.
Yeah.
I hate her.
I misread the rules.
Okay, what is the name of this evil function?
I don't remember it. I
Natural-
tried to ignore
natural
it.
log.
It's not natural log.
Okay, is it just a logarithm?
No, it's not a logarithm.
I'm out.
It's like 3
Expon-
point or 2 point.
It's an exponential function. Write that down.
Okay.
It's the natural exponential function.
I hate her.
Now, it's a little bit easier with 2 to the x. It's a little bit easier with 2 to the x. Like, for example, give me an x and make it an integer. Give me an x. 4. If I've got f of 4, that would be wherever I see the x, I'd put the 4, which is 2 to the 4. Explain that to your little sister.
2 times 2 times 2 times 2.
Times 2. Exponential functions are really powerful. Write that down. Exponential functions are really powerful. And let me give you an example. I mean, now that they've added an extra week onto break and totally torpedoed our spring break, let's just say you go home for break and you're like, Mom and Dad, you know, now I've got a month. And for the next 30 days, I'll just work for you instead of getting a job. I'll work for you. I'll work for you for 30 days in a row, and I'll work 8 hours a day. And by 30 days in a row, Dad, I mean 30 days in a row. I'm not taking off any day whatsoever. I'm working Monday through Sunday. I'm working Monday through Sunday. How many hours a day? 8. So let's just say it's day 1. You put in your 8 hours. You put in your day 8 hours, and this is your pay. One honest Abe. One honest Abraham Lincoln.
For 8 hours.
Are you liking this 30-day deal? Are you liking this 8 hours? You're like, now we come to day 2. You work 8 hours. You get 2 little Abraham Lincoln pennies. 2 copper, fake copper, little Abraham Lincoln pennies. Day 3, you get 4 little Abe. Day 4, how many do you think you get? How many do you get? 8 little Abes. Day 5,
16.
16.
It's still
Day
really
6.
32.
Okay, good. And then at the end of the first of your 30 days, first week of your 30 days, how much are you getting? 64 cents. So you put in 56 hours and you've gotten paid about $1. Are you digging this deal? Are you digging this deal?
No.
Are mom and dad digging this deal? Are mom and dad digging this deal? Like, can you imagine what they're having you do? They're having you clean your room to start with and get rid of all the crap you've got everywhere all over the house. I'm just talking about my own daughters here, okay? And then you're asking you to, like, oh, 8 hours? Why don't you paint? Why don't you paint for me? And then they're like, okay, why don't you clean up all the messes you did painting? Then they're like, okay, why don't you go mow the yard? Why don't you clean the gutters? Why don't you? Okay, so let's keep going.
Most of those things for free. I'll take the dollar.
And let's go up to day 30. Let's go up to day 30. We keep going. And we're wondering what's our pay for day 30, the last day, before I go back to JMU. Well, let's see. This is like 2 squared, true or false?
Sure.
This is like 2 cubed, true or false?
True.
This is like 2 to the 4th. So day 5 was 2 to the 4th. Day 6 would be like 2 to the 5th. Day 30 would be 2 to the 29th. Take out your calculator, or take out something and do 2 to the 29. And just tell me, just read off the numbers for me. Just read off the numbers. What are
5, 3, 6.
they? What do you have?
5, 3, 6, 8, 7, 0, 9, 1, 2.
Did anybody else get that? Anybody else get that? Okay, now these are pennies or dollars? These are pennies or dollars?
Those are pennies.
So if I do that, then that's dollars.
I'm liking this deal.
Yeah.
So how much is your last day's pay? How much is your last day's pay? Yeah, are mom and dad feeling had?
Yeah.
And you're like, well, you shouldn't send me to calculus. You should not have sent me to calculus, mom and dad. Now I gotta ask you, is this idea of doubling, is that a pretty powerful thing as it
Yeah.
continues?
No,
Do you see why they're so concerned about COVID?
Yeah.
Yes.
Because it doubles every 5 days if you don't get it under control. If you keep the people going out and you don't control it at all, do you see in how a very short period of time you can do the whole world in a very, very short period of time? It's doubling every 5 days. Is exponential growth powerful? Is exponential growth powerful? It's the same way, guys. It's the same way. And this is again. Let's go back to your beginning. Okay. There's an egg, and there's the sperm. Okay. Then what happens?
Sperm fertilizes the egg.
Okay. And then what happens? Did you guys learn nothing in high school?
not
No,
six
it
that suck.
sucks.
Yeah.
Then you end up with 2 cells. And then you end up with 4 cells.
If you
You guys realize like that stork did not, I mean, just making the sperm fertilizes the egg, and then you have cell division. And my, like, every time, my daughters, did I tell you about this, how they say they're so unlucky? Have I heard you tell you about this?
No.
That's like, my daughters told me this, they're like, you know, I'm just so unlucky. They mean, like, they get to a point like, I gotta delete this, remind me to delete it. I'm just so unlucky, and they're like, I'm like, you're unlucky, and she's like, yeah, like, I'm so unlucky. I'm like, why are you so unlucky? Well, just nothing ever works for me. Nothing's ever worked for me, Dad. And I'm like, okay, you're born in the United States, right? And she's like, yeah. I'm like, you could have been born in Rwanda. Okay, you could have been born in and I'm like, you know, when it's underneath 60 degrees, you're freezing. When it's above 80, you're burning up. You're sweating to death. You know, 60 to 80 is the only temperature range you can live in. And they're like, I've never had any luck. And I'm like, okay, you've never had any luck. There were 240 million other sperm going for that egg. And who got there first? Whose sperm got there first? That would be your sperm got there first. 240 million to 1, and here you are, complaining to me. So everybody in here, to be alive, beat the odds of 240 million to 1. Are you all lucky? Yes. So, yes, no. Can you imagine me being your father? Okay. Then they divide again. Then they divide again. And then they divide again. Like Dr. Warren, you can't draw that many. Are you really? Okay. So here there's like 1, 2, 4, 8, 16. And they call these division cycles. This is one cell division cycle. This is a second cell division cycle. This is the third cell division cycle. This is the fourth cycle. Do you know how many cycles there are between this and then when they give birth to that screaming child?
So many.
No.
I have no clue.
39.
Oh, wow.
1 for each week. 1 for each week. They got 39 weeks.
I'm learning more in this class than
Yeah.
I said that I did in sixth grade.
So is exponential growth pretty powerful? Is exponential growth pretty powerful?
Yes.
I mean, what do you think? Like, you think cells are like popping like popcorn? Like it instantly, like it's like, you know, no, it takes a while. It takes a week for that thing to divide. 39. It's how somebody can be completely healthy, get diagnosed with cancer, and be gone in almost that same amount of time. And be gone in almost that same amount of time. You know, it's exponential growth is incredibly powerful. And one of the most evil ways it's used is with credit cards. One of the most evil ways it's used is with credit cards. Because they hook you in to that exponential growth working not for you, but against you. Guys, if somebody's sending you credit card offers in the mail, how much money are you making? What's your job? You're going to school. Why would they send you credit card offers? When you get those, what do?
Shred 'em.
You shred them. Throw them away. What did I say? They're evil. Say that. Look at somebody and say that. Do not get trapped by exponential growth.
They're evil.
How many of you are already trapped by exponential growth?
I mean, I have
Student
one,
loans?
so-
Oh, yeah.
Did they send it to you in the mail or did
How many people have student loans?
Oh, there you go.
Pay those off as quickly as possible. Okay. E to the X. Oh. Why do you stop me? Why don't you stop me?
What time is?
Oh, I'm
Jeez.
Oh.
Dr. Warren, don't you teach anything other than stories? Okay, have a safe weekend. I think the COVID dashboard is to reflect Halloween today. I think the COVID dashboard reflects Halloween today, or Monday. All those tests should be coming back.
Have any more of your students on there?
On the dashboard?
Like, have any more of your students told you that they got COVID after Halloween weekend?
I haven't had one yet, but it's a 5-day waiting period, 5 days until, so I'm thinking this weekend maybe though, thanks. Where we go, that would be, yes, let's, what do you have on Monday at 2?
Right.
Right.
But I don't think I'm meeting for it, so it's probably not.
Well, just let me know.
Okay, yeah.
Okay, and if so, then we can just meet in my office and I can set you up over in Hall.
Perfect, okay, yeah, I'll just send you an email. Alright.
I was looking at my old AP Calc notes, right? And then, so I think I was taught second derivative test like a different way, and I wanted to ask like what the difference was between that. So I think I wrote it down. It was like find the first derivative, find the critical points, find the second derivative, and then plug the critical points into the second derivative.
Right.
What's the difference between that and like this? How?
So the way we're doing it is superior.
Mhm.
In that typically for most models, kind of like what we were looking at earlier, when you take the second derivative, it ends up being a real mess.
Mhm.
The more complicated the model, the harder it is to take a derivative. And so what we're doing is we're using increasing and decreasing, and then reading our local maxes and local mins off of that. You can use the second derivative test, which means that you take the first derivative, the second derivative. If the first derivative is 0 and the second derivative is smiling, then you know you've got to have a local min. If the first derivative is 0 and the second derivative is frowning, then you know you have to have a local max. But I don't teach that just because it's the first derivative test is usually the way to go.
Yeah, well, Keenan and I were talking
we
about
were
it
talking about it.
afterwards, and he was like, "Did you learn it this way?" I was like, "No, but this way's so much easier than the way I did learn it." I
Yeah,
was
you
like,
just,
"Why was I
you're
not
making a
learning
sign
this
chart
way?"
for the first derivative, since you already have to get the critical points, is
Yeah.
just usually a much easier way to go, so.
Yeah, I don't know why they didn't
Yeah, I
just
know.
teach it
It's
just
the
that
College
way,
Board.
yeah.
No, right.
I'm not sure
because
with
they're
college
expecting-
board,
And there are
although,
certain applications where it is really
Some.
useful to
They
use
use
that
the-
derivative
although I
test.
do remember exponential growth to a certain degree, and I didn't know anything about it, so this is a whole new experience.
I'm
with
gonna
current
pull up all of
college.
No, yeah, no, I mean, like, kids don't get exponential growth, you know, and it's shocking when you see, wait, these are pennies, and just within 30 days, we're talking millions of
Yeah.
dollars.
Mhm.
You know, it's
It's a lot.
a lot.
Are we allowed to exit that door? Or
I
will it
do
be
every
us?
day, I do.
Oh, you
no,
do?
no,
that's
I was
fine.
always like, I'm like, it looks like something in a store, and I'm afraid a fire alarm's gonna go
Yeah,
off.
it's
It
Well,
looks
you know,
like
I
it's
just,
just metal.
I just can't help but push buttons like that, so I'm
I
like,
think
yeah.
it's right there.
It's right there, yeah, have a good
I
weekend.
don't know.